Big learning, yeah. The learning. I think I'm gonna change the playlist. I think. Hopefully it's not too low, but I don't want it to be too loud either. All right, I think I'm gonna do this for like maybe an hour, maybe an hour and a half, and then I'll play the game. That one game that everyone likes to play, but not really. Okay. Let's see. Okay. What else do I know? What do I need? What do I know here? Okay. We want to show this. What the? Oh, it's not infinite. It's not infinite. Okay, it's not infinite. And then we want to show the finite sum, the lengths is greater than or equal to 1. Got it? This made me remember that I need to study for my first midterm exam for mechanics next week. What mechanics are you learning? Are you learning like are you learning Newtonian mechanics or Lagrangian mechanics? Hamiltonian mechanics? Classical? Okay. So you're I'm assuming you're studying Newtonian mechanics, but probably you're probably gonna cover Lagrangian sometime later, maybe. Unless it's like even it's a more elementary than that, then it's just Newtonian. Yeah, the Lagrange last 5 weeks. Cool, cool, nice. That's a good class. I really like that class. Specifically the later part where you get to not really like use the Lagrangian, but like apply it to like orbital mechanics, and um, non-inertial frames. Like those, that was the highlight for me when I took a classical mechanics course. I don't know if maybe not every class probably teaches those, but like that was something I had to learn when I took classical mechanics. So what is it you're covering for your first midterm? Okay, what was I doing here? Everything until kinematics? Okay. You have like drag problems? You know, like those projectile motion problems where you actually have friction or drag? A lot. That's funny. When I took classical mechanics during COVID, and there was this problem that we had on our midterm. It had to do with it had to do with um coughing, and then like the cough particles that spewed when you cough, like the spit. And like the problem was basically how far would the spit go? And then we basically obviously used our mechanics from the class to calculate that. But it was a little bit more. It was a little bit challenging because um, what was it about again? It was weird because of a specific case. I wasn't able to solve it like using the typical drag equation. Um, I remember the problem, but I don't remember how I solved it. It was like so long ago. But I remember that problem was so hard. But I was able to figure it out like literally in the last 5 to 10 minutes of the exam. I was able to figure out what like the trick of the problem, and I was so happy. But I was also so lucky because it was like last minute. It wasn't like typically those problems are like plug and chug. Like if you know the drag equations, you can like just plug in like um, the parameters and like the t and stuff like that. But that one was strange. Systems with no interaction. Yeah, that would be great, huh? Yeah. Why can't we live in an ideal world? I might actually still have that problem. Actually, let's see. Let's see if I have that exam problem. I for sure don't think I like deleted it from my archives. Yes, tensor. Where would it be? I have like so much shit in here. I need to clean this out. Holy moly! I gotta get rid of these like sessions notes specifically. But I just feel like I'm gonna use them one of these days. Yeah, I keep everything because it's like it's like it doesn't require too much storage besides virtual storage. And also I kind of keep things if I like feel like I'm gonna need it one of these days. But like that's like a hoarder mentality, you know? Like I've never needed these things, but like there are some problems in here that are pretty good that I solved. Like when I either tutored somebody or that was assigned to me, and I just don't want to like I don't want to delete them to like have to rethink about it again. I guess, although it's probably good practice to do that. Where is it? Brother, don't tell me it's gone. Okay, CM, I think is classical mechanics. So there's my final. Yeah, I think this is it. Let's see. Where is it at? I'm pretty sure it was midterm one. Ah, there you go. This is the problem. Holy shit. There's the first one. And here's the spit part. I already deleted more than 100 gigabytes. Oh my gosh. Yeah, yeah. I'm probably gonna end up doing that too eventually. I'm like, I'm very like, I don't know. I feel like I need to keep everything because it's hard to remember everything, like all the fine details. Like for this problem, it was the critical part of this problem was to um, take the ratio of the linear and quadratic terms. Yeah. So this L stands for linear and this Q stands for quadratic. So typically in drag, when you learn mechanics, when you learn drag and mechanics, you only really learn the first two terms, which is quadratic and linear drag. Did I do this wrong? I feel like one of them should be. Yeah. Oh yeah. This is quadratic because the V is right here. So you learn the first two, the linear and the quadratic, but sometimes in problems one dominates either the linear or the quadratic, so you can just approximate the problem using one of them instead of both of them at the same time. And then for this one, the trick was basically to do the ratio. Um, these ranges are far enough from QL or Q equals 1. We could say that FL dominates, and then, oh my gosh, I forgot what happened here. I think it was the flight time. It's hard. I had to like go through this again, but there was something weird going on that I couldn't use the equations to solve. Is this Hawk-Tuah formula? Yeah, the Hawk-Tuah formula. This was before Hawk-Tuah even was even formulated. I was doing it already. I could have been rich, making me realize that classical is really taught the same everywhere. I hope so. It shouldn't be different anywhere. I mean, the difference obviously can come from like the school you go to, like the tier. The material is obviously going to be the same, but like the types of problems are like they can be extreme or simplified. But I think the problems that I had were kind of like in the middle, a little bit more on the challenging side, but not that much more. This one was like for sure challenging. This is probably the hardest problem on this exam. and was like the problem that like differentiated people from getting an A to a B. Um, yeah, good old mechanics. This right here, by the way, I was actually gone for like, I mean, you guys already know I was gone. I was gone for like 2 months. I was working on this stuff right here. I'm still working on it, and I've already gone through this. I'm just kind of like, I'm sitting in a class that is that's teaching this subject just to kind of like solidify it, and I'm doing their homework problems to kind of practice through it. But I basically spent the whole summer working on this stuff. Um, and it was I built these notes from all of those 2 summers. So these are the notes that I was working on. Oh, this is the most recent one. So this is like the polished version of the first notes I did. I haven't polished all of them yet, but like basically what I did was I did this is the book that I had to use when I took this course last year. And when I first took the course, it just kind of went over my head a little bit. Like I understand some things, and like some of the things I was able to like I understood enough, but like there were a lot of fine details that went over my head, and I spent the summer kind of like going through um, those fine details, and there was a lot. There was a lot of details that are not written in this book that I had to work through, and it was insane. It was insane. Like I probably either doubled or tripled the amount of words from the book that were not written. Our current grading system for A is 93. Oh, and that's standard. That's standard. That was like I thought like that was like the minimum for A minus, and then A minus greater than 90, B plus 80 greater than 70. Yeah, yeah, yeah. I just want to get an A minus. I already know low key gave up on an A, especially for the proof class. Interesting. Wait, is that the grading system for your mechanics class or the grading system for your math class? Oh, mechanics. Okay. You should always try to get the A, even if it seems like it's out of reach. Because if you aim high, right? If you aim high, then you can only, you know, the potential's a lot better for you to get that A minus. 94 for an A? Oh, that sucks. That really sucks. That's actually brutal. I don't know why that. I feel like math is harder, man. To be honest, like math is hard. It's harder for me, um, which is why I'm doing my master's in mathematics. So like having that bar a little higher is like this is bad. Joseph, I remember you saying that you're EU, you're European. I feel like you are awake during NA time. Are you North American or European? Maybe I misunderstood. Honestly, from the times that I always sometimes look into like the other math streamers. MA, okay, that makes a lot of sense. Like I would see you and the other math streamers. and it would be like always in the middle of the day of NA, like, and I was like, what the heck? This guy should be asleep right now. But I was like, I thought your schedule was just very strange in EU. I was like, oh, well, I guess everyone has a different schedule. But that makes so much sense. That explains it. Yeah, I wanted to confirm for specifically that reason. MA is what is MA? MA is don't tell me, don't tell me. I'm gonna guess. MA is I only know two states with MA. Wait, is that a state? Maybe it's not even a state. MA. Yes, a state. Yeah, yeah, yeah. It's not Michigan. It's not Missouri. What other states start with M? Why am I blanking? Classic American. Don't even know their states. Holy moly. Okay, tell me what's the state? Is it Hey, that's what Google Maps is. Oh, Massachusetts. Oh my gosh. It's the one that everyone struggles to spell. Yeah. At the very least, I know roughly where certain countries are. I'm not gonna be like those people on those videos that thought that thought Korea was like north of us or something like that. I'm not that bad. You've taken, you probably interpreted my Cambridge. Oh yeah, probably. Ah, I see. Yeah, that makes sense. I'm curious. Have you taken measure theory or like a graduate real analysis class? Does this look familiar? Nope. So the proof class I'm taking right now is integrated multivariable linear. Okay, okay, okay. Manifolds, nice. That's nice. If I were to take a proof class, that's exactly what I want in my class. That's a little bit of analysis, a little bit of algebra, a little bit of topology, um, multivariable. That's nice. That's a good mixture. Okay, what was I doing here? So A is contained in the union. This implies Measure of A. And I think this is supposed to be less than or equal to some. The notations are definitely familiar. I just don't know how to approach them. Yeah, yeah, yeah. In math, the notations are basically going to be they have to be the same because like it's like the grammar, right? The it's part of the language. Yeah, this is a bunch of like set theory. There, it's topology and set theory. They usually go hand in hand. Typically, like if you learn topology, you should have like a good understanding of set theory. But this is like typical set theory stuff like intersections, set differences, containment. Um, it's just an application. It's like a topological application. Do you know of any get smart quick schemes asking for get smart quick schemes? No, unfortunately, Maki, you either have it or you don't have it. Like me, I have it. Now, do you have it or do you not have it? I'm obviously kidding. But I mean, if you ever want to, if the fastest way to get smart is to find what works for you. Like, what's the best approach that works for you? For me, my experience has shown that if you if you develop the discipline to read, if you force plastic surgery on a smart person for hire, exactly. There you go. I don't even have to answer the question. There's a lot of there's like a lot of people write books, right? And the thing about books is they're written typically written differently. Some of them are written the same because like some people copy each other and just do small changes. But if you develop the discipline to read, then you have all these options of like picking a book. Obviously, buying books is expensive, so like you can just find PDFs. But that, in my opinion, is like one of the best ways to learn fast. Is being able to have to build a discipline to read and then knowing what type of books work best for you. Um, and then that should also be supplemented with like videos. Videos are good. It's just they're just not peer reviewed. That's the bad thing about videos. Like typically books are peer reviewed, and so like there's less likely there's a less there's a smaller chance that what you're consuming is incorrect. But I can make a video on this stuff and can be completely wrong, and then someone's gonna be watching and be like, oh, that makes sense, and it's completely wrong because what makes sense to me could make sense to someone else. You know what I mean? Which reminds me, I need to make videos. I need to start making videos. What was I doing here? Oh yeah, I was doing this. I'm not buying whatever Pearson or McGraw access code you're selling. Hey, I get, I know exactly where you're coming from. Those are scams. I'll admit. Especially like books like the university textbook. Oh my god, those things are huge, and then they keep producing new versions every like 2 or 3 years, and the price of those are like $300, and it's like the same stuff. They just slightly change a few problems, maybe a few diagrams. It's a scam, man. Scammed. That's how you know when your professor is a G or not. If they make you buy that book, they're not a G, bro. They're a scammer. They're a bot. They're just a part of the system. Then you're not legally allowed to use the international version. That's like 1/10 of the price. Yeah, yeah. I remember when I first heard about the international version. I was like, oh, I can't buy the international version. It's not. It's bad. I still don't buy the international version though. I would buy the actual copy because usually the international versions are like soft covers, and I hate soft cover books. Those are the worst. I only buy it if it's the only book. Okay, I need to figure out how to get this less than one. A man of culture. Yeah. I actually did buy some soft covers recently because they're the only ones they only sell it in this. I don't know if you've ever heard this book. It's called Real Analysis, a long form mathematics textbook. And that book is solid. It is like probably one of the best real analysis books that you can get, at least like the introductory ones. But it's only in paper. It's only in paperback. And the quality of the binding I heard is not very good, so that's the downside. But it's really cheap. It's like $30, I think. So it's a good book, but it's probably gonna fall apart in like 2 years. How do I get the one on the left? I think. How do you get the one on the left? Okay, this is where I refer to the PDF document. This guy Royden. Um, Something about intersections. So A is less. A is a subset of. Okay, let me write this down. A is a subset of 0, 1, right? So from this implies that A is a subset of 0 to 1, and that implies that the measure of A, or the outer measure of A, is less than or equal to 1. Okay. Wait a minute. But A is also a subset of Q. Huh? Wait, huh? So, oh, wait. A is also a subset of Q, so the measure is 0. So A is also a subset of the rationals, and so the measure of A is less than or equal to 0, and this implies that A is equal to 0. Okay. So A is equal to 0. That doesn't help me. That doesn't help me. I need to somehow get the 1. I had to get the 1 somehow on this side. Um, to get the 1 here. So there has to be a sequence of inner open or sequence of intervals that cover A but are greater than the interval. Okay, that I kind of see where this is going. And Stucky, good to see you. Nice to see you. How are you doing? How's it going? Okay, okay. What does this problem say? Does it be open intervals such that A is contained? Okay, so A just needs to be contained in this. Okay, so maybe I can generate so I just have to find some interval. I just have to find some interval. So let's just say that our intervals are intervals. Each I sub k is some open interval for q sub k minus um, the book that I was saying, but it redirects me to IEEE Explorer. Are you talking about you talking about this book? Hold on. This one? It's a thick book. It's one of like the thicker real analysis books. But it's worth it, man. Everything. Look at how nicely look at how nicely boxed things are. Like it's clear where propositions are. Let me show you a highlight of something of this book. Hmm. Gonna try to convince you to buy it because it's only $30, bro. Oh, I guess it doesn't do that for every chapter. Look at this. Look at look at this. You see that chart? Maybe I should probably get a PDF of this. I just can't find a PDF of this. That's the reason why I bought this book too. Like I can't find a PDF of this book. It's so hard. So if you find one, please let me know. There is a table, um, basically a table of properties for pointwise functions, the convergence of pointwise functions, and what type of properties are conserved in those things, and like it literally makes a table for you. It makes a table for you so that you can refer to it and you can remember what properties are conserved for these types of um, for this type of um, mathematical object. Like that is nice. It doesn't happen throughout the entire book, but like the fact that it even happens at all is really nice, and it like goes through each one as a checklist, and some of them is assigned as like exercises for like homework, but a lot of them is like worked out. Let me see if I can download it. You found one? There's no way. Maybe it's the proofs book because he also has a proof book. Damn, so nice and thick. Yeah. 30 is still lunch. That's true. That's true. Unfortunately, that's true. Why is it lunch? I never had the good old days when it was like only $8. Okay, I want to make the interval. I think I could choose whatever I want this to be. $20.21. Yeah, that's when it was published. Do I have this book? Now you're making me second guess. Like, do I even have this book? Which one is the one I struggled with? Bro. I don't have it. I definitely don't have it. Let me see if it's available. Oh my gosh, I can't find it. So what the heck can't I find? Is it the proofs book? I can find it too. Actually, I remember what happened. I couldn't download it for some reason. Hmm. Well, if you can download it and send it to me somehow, that would be great. so I can have a PDF of it. Okay, so what was I doing here? So actually, I think just showing one case is not going to be enough right here, right? So it just needs to cover A. It just needs to cover A. Okay, so why don't we do this? Does this work? Okay, so the length of IK is just going to be the difference between the two. So it's going to be um, 2 epsilon over 2k plus 1. I think I chose the wrong term. I think it's over 2 to the n with 2n. And this gives me epsilon over n. And so when I sum, I get epsilon. Okay. What am I doing wrong here? So this clearly works for epsilon greater than or equal to 1, but and then so you have countably infinite many rationals inside that interval. And so this is not really like, so I sub k. hmm, oh wow, Pav shows up. Let's see, what am I doing wrong here? Oh my, don't tell me this is gonna take me the entire time. I thought I was gonna be able to do two of these problems. Just forgetting how this works. So the idea makes sense. The idea makes sense because we can if A is contained in this union, then these intervals basically have to Because A is the intersection between the interval and the rational numbers. So like A is like spread out throughout 0 and 1. And if A is contained in this interval, then these guys also have to do that too. But 1 is contained, 1 and 0 is contained in A, so there has to be an interval containing that. So that means this should be larger than 1. I just can't like formally write it. How do I write this formally? Maybe there's some properties that I need to use. I just can't figure it out. Digital reserves copy. Got it. Thank you very much. Nice doing business with you. Nice. Awesome. I have a digital copy of this. So if this is the only one you can download, then it must be difficult to find the digital copy of this book in general. You probably only like found like one, right? I think I can string together I could string together a like a dirty argument for this, but I feel like there's a clean one. Should be a clean argument for this. What would it be though? Okay. Okay, so this, I think I just need to show that this is contained in this. If I can show that this is contained in this, then that finishes the proof. And it's obvious that it is contained because A is contained in here. But what's the logic that's the formal logic that shows that containment? I think it has to do with the density of the rationals. Okay. So A in the union K equals to 1. This implies no, that's not true. Hmm. Mr. Incredible. I am Mr. Incredible, Paps. Are you trying to say I'm not? Okay. Let's see. Man, it sucks. Like I know exactly what's going on in this. I just can't formalize it. Holy moly. There has to be like some trick. Get back to work. Let me think. Oh, I'm supposed to write it like this. Are you working right now, Paps? The heck are you doing? You should get back to work. So the idea here is that there are rationals between 0 and 1. Those are my rationals. And we're supposed to cover it. So like this can be one open cover. Be another one. It's basically n. It has to be done this way because it has to cover all of the rationals. Oh my no, I'm Zeldaing. Zelda. Like the Breath of the Wild or like one of the older games? They didn't release a new Zelda, right? Zelda. The new one, Echoes of Wisdom. You play as Zelda. Oh yeah, I heard about that. That's right. Yeah, I think people were saying like they were trolling and saying like, "Oh, it's the Legend of Link," or the roles are switched, sorta. Is it this? I think it is this though. I think it is this. Hmm. Mm, no, it probably isn't. Yeah, I somehow need to show that this is contained in this. I just don't know how to show that. This is contained in this because of A being defined as the intersection of this. Holy moly. Okay, I'm gonna write the loose argument instead. So I have something done. Okay, since A is equal to 0 to 1, intersect Q, A is the set of rationals Rashes are dense in R. Um, A is subset of this union. Is contained in this. Okay, that's the loose argument. This is the part that I need to look at again later. Okay, I think I know what's going on here. I have to like remember some topology stuff. Where's it at? Where'd it go? It's not that one. The heck? Where is that book? Oh, there it is. Okay, so I need some properties for closure. If A is a subset of B, then the closure of A is equal to the closure of B. Okay. So this is the closure of A, subset of the closure of this. Mm, and this, and so the density just, this implies that this is just equal to 0 to 1 by the density. Okay, is there any properties for the union? I'm actually curious. Hmm. So there's interior. There's an interior property. What about the closure? Oh, great. I have to figure that one out. Okay, I'm not gonna try to figure this out. You just Google this. Let me see. Well, let's try to figure it out real quick. See if we can figure it out. So if A and B are sets, you take the union, a closure. I think it's equal. I think it's equal. take a look. All right, let's take a look. Transition. And then we're going to look at closure properties. Topology. Okay, it's true for finite. Okay, so it's true for finite. Okay. So this says that this is equal to the union and k is equal to 1 of the closure of ik. Okay, and then from here, we get that this less than or equal to. Which is the same thing. This is the same thing. And so, and this was 1. And this was, okay. This was 1, this was the length of ik. Okay, I got it. It did involve the density, but the details were a little bit um, topological. Okay, nice. That's good. I guess that was one problem, which is I guess a victory. All right, I'll be right back. I'm gonna go to the bathroom, and then I'm gonna switch categories.